Hi guys, I am so sorry to leave and not be able to walk through this with you, but hopefully this helps you guys complete this. So we've been talking about linear equations. Remember, our most favorite version of linear equations that we used all the time is this y equals mx plus b, the slope-intercept form. And now we're going to move in for our next unit into kind of real world situations that end up with this linear scenario. So when we look at example 1, rain fell at a steady rate of 2 inches every 3 hours. Steady rate is your key that this is a linear situation. If I graph this data, I'm going to see that we are rising and running at the same amount, 2 inches for every 3 hours that we go over, and it will be a continuous, nice, beautiful, patterned straight line. So if I look at the information I got here, rain fell at a steady rate of 2 inches every 3 hours. If 0 hours have gone by, that means we're going to have a rainfall of 0 inches. Doesn't tell me anything's happening prior to that. After 3 hours, according to this, well, it's 2 inches every 3 hours. So after 3 hours have gone by, I'll have 2 inches of rain. If I try and think about, well, how long is it going to take to have 4 inches of rain? Well, then it's 2 inches every hour, so 2 and 4, 3, then 6 hours. And then you kind of see, oh, they're just following a pattern. 0, 2, 4, 6, 0, 3, 6, 9. Okay, and then if I go up 3 more hours, I'm going to add. So if I increase by 3 hours, that means I'm also going to add 2 more inches to get to 8 right there. So again, I know it's linear because it's a steady rate, but if I actually graph this information, I start out with 0 hours for 0 inches. After 3, so if you look carefully, this is actually counting by 2s here. So if I go over to 3 hours, I go up 2 inches up here. This is also counting by 2s, 2, 4, 6, 8. If I go over to 6 hours, it goes up 4 inches. 9 hours goes up 6 inches. And then 12 hours goes up 8 inches. And you see what a pretty linear line this is. It's all lining up nice and beautiful. Now, as far as just an old vocabulary word, this is, as far as continuous or discrete, this is a continuous situation. Because if you think about our data, even though I only have 3 hours, it's 2 inches, 6 hours, it's 4 inches, it doesn't just like there's nothing that happens, then all of a sudden after 3 hours, it dumps 2 inches of rain, right? The way rain works is it starts out and it rains and rains and rains and rains. And then after 3 hours, you notice, hey, there's 2 inches in the little rain gauge. So when it is continuous, you're going to have a nice line through that data, a continuous line. All right. Now, when I start going to try and find the slope, there's 2 different ways you can do this. You can pick some points on the graph and do like a rise and run situation and simplify that down. So let's see, if I did this, I would see that it's going up 8. So I'm rising 8 and I'm running over here 12. So 8 over 12, okay? Which then if I simplify that down, divide both those by 4, I end up getting 2/3. Or if I go back to my table, if you look, you can see that your x-axis is your time. So this is my x. My rainfall is on my y-axis. And so if I think about, okay, well, this is rising 2 every time. This is rising 3 every time. And then some of you guys are having some confusion over this. Remember our cute little rhyme? You rise, you get your rise from the y's, and you run from your x's. The run values are going to come from your x. And we know that slope is rise over run. So I'm going to go 2 over 3. Okay? Now, as far as real world situations, we want to think about what this slope actually means, what significance it has. So I'm going to put some labels on this. This says, okay, the 2 came from here. So 2 is my inches of rainfall. 2 inches of rain. The 3 came from up here, so my 3 is my time, my hours. And then we just got to turn it into like English that makes sense a little bit. 2 inches rain, 3 hours. Well, 2 inches of rain. And then for this fraction bar, I can think that as somebody second period was saying 2 inches of rain over or on top of 3 hours. On top of doesn't really make sense, but if you say over 3 hours, that kind of makes sense. What I like even better than over is for every 3 hours. That's what a fraction really means, like 2 for every 3 or 2 per 3. Okay, so 2 inches of rain for every 3 hours. Well, that makes sense. I mean, it's basically exactly what I have up here. 2 inches of rain every 3 hours. My y-intercept for this situation is right here at 0. And I think about what significance does that have, 0? Well, 0 is where I start. I start with 0 inches at 0 hours, okay? Then we just bring it back to the math a little bit. We've been talking meaning and real life. If I bring it back to the math, I'm going to say, okay, y equals my m value. I know my slope is now 2/3, then an x, plus my y-intercept is 0, which I don't really have to have that plus 0 on there, but you can. It's not going to hurt anything. So you don't have to put that on there, but you can. Okay? Our next situation, rain fell at a steady rate of 2 inches every 3 hours. Hey, that sounds pretty familiar. The rain gathered in a rain barrel that already had 5 inches of water in the bottom. Okay, so at 0 hours, my water in my barrel is actually starting with 5 inches already. Okay, that's like my starting value right there, 5 inches to start. After 3 hours, what would my new depth be? Well, it says we're falling at a steady rate of 2 inches every 3 hours, so that means I'm going to add 2 inches for this 3 hours, so that would go to 7. Then I go 3 more hours, so I'm going to add 2 more inches to get to 9. We add 3 more hours from that, and we get 2 more inches to get 11, and then 13 to finish out that pattern. Okay, I could draw the graph over here, and you will draw this graph. Okay, take a minute. It's kind of annoying because none of the values are real consistent or pretty on the graph because we're still counting by 2s. But you'll see that same nice straight pattern. This one is also continuous for the same reason that the first one was continuous, okay? Rain does not just happen all of a sudden after 2 hours and all of a sudden after 2 hours. It's continuously gonna be rising. So my slope, okay, I'm gonna remember this is my rise, or that's my y, so that's where I'm gonna get my rise. My run is gonna come from these x values up on top. By the way, x always comes before y in a table. So if it's a vertical table, the x comes left and then the y. If it's a horizontal table, x is on top and then y. But for slope, you put the rise over the run. And again, if you think about this, okay, so 2 is the depth of my water. So I'm going to get 2 inches of water for every, that fraction bar I'm going to read as for every, well, the 3 came from my hours, for every 3 hours. So that's, you're just making a meaning. Oh, 2 inches of water for every 3 hours. That's my rate of change. It is changing 2 inches for every 3 hours. The y-intercept of this, well, if I do go and start graphing it, I start at 0, 5, then it goes out to 3 and 7. So my y-intercept would actually be at 5. Okay, I can see it right here because it's where my 0 value is. Well, the 5 represents, let's see, well, at 0 hours I had 5 inches. So 5 inches of water to start. That's the significance, okay? Like, yes, there's a 5 in the data, there's a 7 in the data, there's a 9 in the data. Well, what makes the 5 special compared to the 9? The 5 is where we're actually starting, okay? It's not just a random data point, it's the actual starting value. In our last situation or example, Ms. Hernandez had $20 gift card to Starbucks. Once a week, she spends $3.50 on her favorite coffee. So if I start thinking about my time, we're always going to back it up to 0. At 0 weeks, how much money is on that gift card? Well, she starts with $20. After 1 week, how much money does she have now? Well, if I take my 20 and I subtract off the $3.50 that she spent, 3 will take it down to 17, and then 50 more cents will take it to $16.50. Okay? Then we're going to go out to 2 weeks. At 2 weeks, we're down to, let's see, that would take me to $13. At 3 weeks, I would drop to $9.50, and at 4 weeks, I would drop to $6. Okay? So at 0, I'm at 20, and then here we get really annoying with the values, and some of you OCD people are really going to be unhappy with me. Sometimes I think it helps if you're struggling, especially when the numbers are nasty, go ahead and label it, okay? So 0 is 20. 1, which would be right here in the middle, is going to go up to $16.50, so not even to 17. Then 2, 13. Then 3 would be at $9.50, just barely under 10. 4 is up to $6. Again, I want to kind of think about that continuous versus discrete. This is, well, let's see, can I have values in between my data here? Can I have money being spent on that gift card in between each week? Well, based off the way this is worded, it says once a week she spends $3.50. So that would make this a discrete situation. So I'm not going to actually connect those dots. If I wanted to continue on and get some more, I could, but I'm not going to connect them. My slope, okay, my rise is going to come from my y. So I'm I'm falling. I'm dropping $3.50 every time. So I'm going to be sure to pay attention to the fact that it's like a negative $3.50 every time. And my run, right? Run comes from the x's. Well, that's easy. It's just adding 1 every time. So my slope would be negative $3.50 over 1. Okay, what does this mean? The negative tells me that I'm spending. We spend. $3.50 is money. So I'm spending $3.50 for every 1 is coming from my weeks, for every 1 week. Oh, that makes sense. We spend $3.50 every week. Okay, so that's how much my value is changing every time. My y-intercept here, well, if I go to my 0 value, it would be 20. What's the significance of 20? Oh, the gift card started with $20. So you're just taking these values and saying, okay, I know the rise and the run and the y-intercept. I know what these mean mathematically. You guys are usually pretty good at writing your formula, negative $3.50 over 1x plus 20. The difference now is, okay, but what do those actually mean? What is your slope telling you about this situation? What is the 20 telling you? So as you move on and do the rest of this packet, I want you to pay attention to the fact that when it says find the slope and y-intercept and explain the meaning, okay? I don't just want rise and run and your number. I want to actually know what's the significance of that. What can you tell based off the labels here? Now, I do want to warn you really carefully about something that somebody did when we were looking at this. It is very common to pick 2 dots and go, oh, that is 1 and that is 2. So my slope is negative 1/2. Okay? No, don't do that. That is wrong. Because look, guys, that's 500. These little blocks are not counting by ones. The bottom ones are, okay? But the top ones, in order to get up to 500, that's actually got to be 100, 200, 300, 400. So that one block that you think it means is actually dropping 100. You cannot just count squares, okay? So it's actually dropping 100, and then it's running. Well, it actually is running 2 because that's counting by 2s. But then you'll have to simplify that down. Well, 100 over 2 simplifies to negative 50 over 1. All right, so I just wanted to warn you about that because that is a common mistake. Don't trust the squares. Look at what you're counting by. All right, I hope this helps. Finish this. It's due on Monday. Good luck.